One and all to the live stream. I don't have everything ready yet, but maybe you can learn something just watching this printer get set up. So here goes. Actually, I think I'm gonna spin this around like this so I can read the chat. So hello and welcome everyone. I'm gonna start reading the chat and seeing what's going on after I get this all set up here. There we go. If anyone has questions about the printer, just drop them in the comments. I'll be checking on that periodically. But, you know, this is going to be a long print job. Lots of plastic to go through. Might as well show you some sample prints that I did. I shared a picture of this on Twitter. I think I might have posted it here too on YouTube. But, you know, it's hard to communicate how big these parts are, but, you know, it's pretty large. This is half the diameter that I can go. This is the full diameter. So, yeah, pretty large. This is the full diameter that I can print. And what gave me this idea was I was cleaning my office, and I realized that this maximum diameter print that I'm doing is the right size for one of these trash bags. These are like one of the really big trash bags that you'll use in a large garbage can. So I was using this as a ring to hold it, but then I figured, you know, just let's print a whole trash can this way. It'll use a lot of material, and I'll kind of show you what's going on the slicer side because I'm having to do some math to get this to work. This is all going to be PLA. You can see in the drawer up there, that's all of my filament that I've stockpiled over the last year, and I haven't really used any of it, so I'm just going to dump it all into this print. And hopefully it'll be something exciting and fun. So yeah, not printing a Gigabench just yet. I might do that later. Yeah, no, this isn't Dr. D-Flow. Sorry, guys. All right, I'm going to be using my phone as a hotspot. So note, this is all standard 3D printer hardware. You can see down there. So this is what I'll be printing today. I know it doesn't look like much, but trust me, this will turn into a trash can. Basically, I'm printing a quarter of the trash can, and each head is going to print a quarter of it, spiraling up around through one rotation. And, you know, all those parts fused together is going to make my full trash bin. And it's going to use about 3.5 kilograms per print head. So yeah, that's going to be a lot. Let me just get everything started. I need to find my USB to USB-C adapter. For some reason I'm using a MacBook, and Mac decided that you don't need USB-A ports. So yeah, this is a constant struggle in a MacBook person's life. There we go, got the dongle. Yeah, sorry you can't fast forward. You're just gonna have to sit through me setting this up, and maybe you'll learn something, which, you know, that'd be awful if you learned something here, don't you think? Drive north and save some of your junk from the garbage bin. No, well, K2 Kevin, I gave away most of the printers already, so there's not much left. Um, I might do a secondary junk haul, so yeah. Hey Zombie, welcome to the stream. Zombie Hedgehog is a prolific live streamer if you don't know him. Okay, export. So I've been running test prints on this thing so far. Trade gear for watches? I don't know. I have just a few watches that I really enjoy. Like this one right here. Check it out. All right, you brought up the watches, so we're gonna have a 30-second detour to go over today's watch. Check out this bad boy. I can start a timer. Look at the little hands go around. It's so fun. Yeah. Anyways, I'm gonna set that back to counting the time. What are all those lines? I don't know which lines you're referring to. Yeah, Casio's the best. Okay, exporting finished. I got my G code here. You can see it's kind of an interesting format of G code. This will all add together to produce my final part. Basically, yeah, the printer thinks it's a Cartesian printer. It doesn't know that it's polar, so I have to do some trickery to get it to work. But it'll work. So I'm just, I'll show you what's going on here. Basically, I just drag and drop the G code into my fluid client up there. That's what the computer's running. It's controlling everything about this printer. The heated bed is up to temperature. I just had it do the preheat. It takes about 10 minutes to heat up, so not bad. Okay. And all right, so I got my G code loaded up, and we're just gonna go for it. Print. Okay, so the only thing that's a little hacky here is, okay, everything's happening fast now. There's the bed spinning, as you can see. Now the Z level is happening. These are all moving down to set their Z height. I'll watch the chat. I think everything's just gonna run now, so I'm gonna keep an eye on things here, but I'll also keep an eye on the chat. Doing double duty. How do you home the bed? Good question. You just saw me home the bed. So this little button up here is the Y-axis limit switch. So I tap that twice to make it think that it tapped the home position. But I don't have a limit on the bed yet. I'll get one installed later. But now that this is locked in position, I can't rotate this bed. It has about as much torque as a motorcycle engine. So, you know, very strong motor there. Much stronger than what you'd get on like a normal thing. Okay. We're just waiting for the bed to heat up another 10 degrees. It's going to 70 degrees. And it's at 64 right now, so it'll be about another minute to reach 70, and then everything will get started. So yeah. All right, let me get some more stuff. I have to collect all my spools of PLA because I'm going to use up basically all of them on this print. Matte PLA. Hyper PLA. Let me put this somewhere you can see it. No, over there. This is a good spot. Okay. So I'm just going to make a tower of all the spools of PLA that I'll be going through for this test. We're moving into position. Looks like it's going to get ready to print. Okay, they're all extruding. Yes, this is beautiful. Check out this extrusion. Yes. We'll have to see how well everything lines up. I actually haven't checked. Oh my goodness, that's not lining up very well. Now if I did this right, things should touch here, but I might have these settings way off for this. We'll just have to see. Let's see what the first line of G-code looks like. Might need to restart this test, so let's see. Oh no, okay. So when we look at how this G-code gets started, this is the first circle that it makes, the first loop, then it goes outwards. And by the time it gets to this outer perimeter, that should be where all the lines are touching. I'm not 100% it's going to get there, but we'll just have to wait and see. Yeah, you know, there's a lot of like math and assumptions that you have to make, and doing geometry and stuff to make sure everything translates from Cartesian to polar properly. So yeah, I'll get you a little closer. You all deserve a front row seat to the print show here. Hold on, let me turn the phone around actually. Oop. There we go. That's looking pretty good. So the other thing you'll notice is that this machine is pretty quiet. It's not the quietest machine in the world, but it's pretty good. That's one of my requirements for all printers, is they must be quiet. Seen and not heard. I think this white arm is raised up a little bit, so I'm going to lower it manually. Yeah. That's looking pretty good. Okay, so if anyone has any questions, I am available in the chat to read what's going on. Huge Simon says, oh yeah, the Bop It game. Endless loop of this printing for oddly satisfying compilations. I have a time lapse of this running from yesterday. But yeah, I'm really going to be pushing the speeds on this thing. Nope. Looks like this cable's in the wrong spot. We'll get it up and out of the way there. So the only weakness of this machine so far is, oh yeah, watching it do something new. Yeah, I'm gonna turn the speed up here. Right now we're going 40 cubic millimeters per second. I think I can go faster. So we'll turn the speed up to 150%. So right now we're doing 60 cubic millimeters per second times 4. So that's 240 cubic millimeters per second. That's already more than twice as fast as anything out there that I know of. Actually, yeah, I'm going to keep the speed turned down to 100 for now. I just want to make sure our first layer goes down properly. One, two, three. So 10 lines. Yeah, I think they'll all combine together by the time it's done printing all of this first layer. And then we'll see how good our tolerances are. You know, the arms all need to be lined up properly. The other challenge here is I'm going to have to manage the spools. When 4 spools are running out at the same time, that's going to be a little bit crazy. So, yeah. Lots to do here. Yes, outside the box. Must think outside the box. Okay, so how much PLA are we going to need here? I've got lots of white, lots of blue. I've got 4 kilograms of gray, 2 of blue, 3 of white. So I'll try and keep the colors somewhat similar throughout the print, but there might need to be some substitutions. All right. Sorry, I'm just grabbing all my filament and getting it stacked up here, so pardon the periods of silence, but I think just watching the printer work is entertaining enough for you guys for now. At what point will I have the print heads running independently? That'll come eventually, but, you know, it's a big challenge in terms of doing the firmware for that. So right now I'm just validating all of the mechanical pieces, but you know, once I get to that point, it's just a matter of programming the firmware and software to handle that extra complexity. But yeah, I'm not tackling that right now just because that's a lot of, I feel like I'd get a little sidetracked. Right now I just want to make sure all the mechanisms work, and then I can move on to the electrical and software challenges. But in terms of electronics, all of these are capable of being controlled independently. I just need to get firmware loaded up that will allow that. Is the print solid or infill? This one will be solid. The idea is to make another print that's similar to my other trash can, which, let me go grab that. Okay, so here's my previous large trash can. This was 4 kilograms. And as you can see, this one is going to be able to easily fit inside of this actually large trash can. This will be like the size of trash can that you'd set out on the curb for pickup, like to contain all your household garbage. So here's all my filaments. I'm just going to be loading this up into the machine. Here's a dramatic view of the filament consumption rate. This is only at half speed too. I can crank this up once I get past the first layer. So you're going to see all 4 of those spools spinning like crazy when I get everything running. Yeah, fastest is in terms of time to complete object, not in terms of how the velocity of the print heads, which is kind of a meaningless measurement if you ask me. Okay, time to see how well everything's lining up. It looks like blue print head is a little bit out, so I need to move it forward a little. There we go. I moved it inwards 1 click, 1 step of the stepper motor, so that it'll line up with everything a little better. Yes. So, yeah, I'm just going to read chat for a little bit. I'm curious what you guys would do with a printer like this. Anyone have any ideas? Any brilliant ideas of how to use this sort of machine? Make a mixer. Absolutely nothing. Keith Sachs, you're a filthy animal. Texas coasters. 5-foot Pokemon. Okay. A giant bullet. TPU top hats. Oh yeah, I could do that. I want to print dunce caps for everyone at like a rep festival. So there's no point in doing input shaper because of the low velocities and low accelerations. I guess, you know, it would make sense to do input shaper later, but you don't really need to. Can I print in the middle of the bed? Yes, I can, but I'm not going to do it right now. The setups that I have right now can't all be at the center simultaneously, but I have some modifications in mind for the next version that will allow me to have them all at the center simultaneously. Right now I can disable 3 of them and let 1 print in the center, which would honestly work fine. You could just have 1 print head handle the center and then switch back to 2 to 4 print heads when you go to the external layers. But, you know, it's fine the way it is. Look at this. These beautiful... yes. I just really like the way this stuff... I like how that looks. So card is into polar. There's ways to handle all of that. It's going to take a while. Hold on, let me get something for scale here. There we go. I feel like I should have a benchy in there too, so let me get one of those. There we go, here's our benchy. Yes, so now it's doing infill. I love it when a machine just works. You know, when it just works, that's the best. Alrighty. Infinite Z. Well, I have infinite Y, at least. So this is using 0.8 millimeter nozzles right now. I think I should really switch to 1.8 millimeter. But it's printing fine as is. What did I say? Yes, R2D2 models is the best use case. I can just crank out R2D2s. Oh yeah, furniture. That's definitely something that I'm interested in doing. Huge Twizzlers, maybe. Let's see. I don't know what else I have for scale here. I think the benchy demonstrates it well enough. Replica German 88 shell, tank gun, okay. Yeah, I want to print some stuff. If anyone wants to buy prints off of this machine, I would definitely be interested in doing that. So, like, I should probably set up a web store or something for that. Unfortunately, it's only big enough for a child's hula hoop. I tried hula hooping with the maximum diameter circle, but it didn't quite work. Ooh, yes. Zombie, thank you for the 149. So I can afford a banana for scale. Standard printer paper. Oh, okay. Yeah, I'll see if I have some of that around. Printer paper. This is an A1 sheet. Not the best demonstration. Maybe a spool of filament. Does that get the point across? Okay, now I have to keep an eye on these filaments for the change out. Ooh, all right, decent farts. Thank you for the donation. That will help reimburse me for the massive number of filament spools I'm going to be going through today. All right, this is ABS. It's a pretty cool color, but don't need that. All right, so I got to line up my next 4 spools of filament. I think I'll switch the natural PLA to a gray. Maybe I'll switch the blue to gray. No, I'll switch the blue to blue. That's going to make the most sense there. So we'll keep blue, blue. Got my good old Hyper PLA from Creality. And if you're wondering why I'm using different types of filament, you know, what my favorite brand is, I just use whatever people send me for free. So, and I do like this Hyper PLA. It's pretty good. Strong, prints fast. All right, so that's going to go over here. All right. This is a PLA, so I'll switch red to red. Then I'll switch white to white. Or I guess this like translucent-ish white. I'll keep it white. So get that over there. And then that last white, I will switch to gray. Just because I have a lot of gray. So, yeah, that'll do. Okay. All right, I've got my my next filaments all lined up, so that'll be ready. All right, so yeah, let me go through some stats for this print. So based on the slicer, all right, so based on what the slicer is telling me, we should be using 3.3 kilograms, so a little over 3 kilograms per print head. But I'm actually going to turn the extrusion multiplier up a little bit just to compensate for the weird, like, geometric things going on here. Basically, most of this is going to be printed at an average radius of 250 millimeters. Oh, this ducky's getting caught. Get rid of that. Hey, these rubber duckies work a lot better when they're heated up. So if you're having trouble getting these duckies to squeak, just put them on a heated bed for a while and you're all set. Do you have remote I/O boards for the tool head axis, like a Duet or something, talking to remote? So the way I have it set up is everything's run using separate boards. So I've got 5 main boards controlling various different parts of the machine. Basically, you know, I've got one per arm down here, and then I've got another main board running that controls everything else on the printer. So the heated bed, the Z-axis stepper motors, all that kind of stuff. The heated bed is at 70 degrees Celsius right now. It can go up to 100, probably even higher than that. It's got a lot of power. All right. This is looking pretty good. How long does it take for the bed to heat? Well, it only took about 10 minutes when I just heated it up earlier. So it's not like a super long time. This machine is, despite its ridiculousness, this machine is designed to be very practical. Like, this is going to be a useful machine for pretty much anyone who needs to print this type of large cylindrical objects, or anything that has like that you can print in vase mode, or if you want to print 4 objects at a time. The footprint of this thing is really small. I'm going to get something to demonstrate a point. Hold on. We have to demonstrate a point here. So let me go get something from the other room. Oh shit. That's... Okay, so look, this machine is not that much bigger than a Soval SV08 in terms of its overall footprint. But you can see the actual usable area is much larger. You see that? So this design is an exercise in packaging to get the most print volume in the smallest area. And also, it's designed to be very user-friendly and serviceable. So, yeah. All right, so it looks like we've advanced to the next layer. This is layer number 2. So we've got a couple more solid layers like this, and then it's going to switch over to, I mean, it's not going to actually be vase mode, but it'll be similar to vase mode. So custom speaker enclosures, not a bad idea. Max Z, right now it can go almost a full meter, I think 900 millimeters. I think it kind of runs into some constraints up at the top. I wouldn't go past 800 millimeters until I've really figured that stuff out. But yeah, it can go tall. Traffic cones, nice. That's a great idea. Those giant ones they fill with water and put on the road. Last video you said functional wheel rim. Yeah. Thank you, Bunny Love. Thanks for the luck. Why are there circles in the center? So those circles are for bolt holes. So the way that the machine's set up right now, I can't go all the way to the middle of the part. And things get kind of weird because I'll need to do extrusion scaling and all sorts of like stuff to compensate for the fact that this is a polar printer. So I just put bolt holes here so I can bolt a bottom plate onto this later. That way I'll be able to have a trash can that's like, you know, doesn't have a hole in the bottom. These brackets I had machined by JLC 3DP. So that's a perfect time to do a sponsor bit. JLC 3DP. 3DP. They have a CNC machining service. I guess it's also called JLC CNC. JLC PCB started out just making PCBs, and they branched out into doing, machined parts and 3D printed parts as well. So, head over to JLC PCB or whatever to try some stuff out if you want to get that going. But yeah, they were kind enough to sponsor a lot of the machined parts on this build, so that's nice to have. And then, you know, the 3D printed parts I just did myself at home. The diameter of the plate is 600 millimeters, so, you know, that's basically, I'm using the full diameter for this print. And hopefully it doesn't come loose, because that would suck. Oh, now I can turn the speeds up. So I'm just going to turn the speeds up here in Clipper. So right now we're going 40 cubic millimeters per second, but I just increased the speed 50%. So now we're doing 60 cubic millimeters per second times 4. So 240 cubic millimeters per second altogether. That's about, hold on, it hasn't sped up yet. I told it to go to 150. There we go, now it's sped up. So now we're doing more speed. And the extrusion is looking a little bit worse now. So I'm going to turn up the flow multiplier to 125. Okay, so now we're pushing, as soon as that flow multiplier catches on, should be 75 cubic millimeters per second times 4, so 300 combined. I'm going to bump the temperatures up to 270. All right, so our hot ends are going to be going up to 270. So now we're printing at about twice the speed as we were at the start of this. But, you know, the extrusion isn't looking as good anymore, and I don't want to have this part fail because I tried to push things too fast. So I might have to turn that speed back down. Yeah, we'll turn it back down. Really, I need to put larger diameter nozzles on here to get the most speed out of it. Yeah, that's looking a lot better like this. You can see this. I'll give you a little close-up so you can see what I'm talking about. So see this, I call it top ramen texture. That's really not what you want to see. Yeah. So this flow rate where I'm going a little bit slower is producing much higher quality, so I think I'll stick with that. So I have some code written to help compensate for like all the different stuff that's going on with the different flow rates, and basically towards the edge of the bed it needs to extrude more plastic than towards the center. So there's like a lot of things that need to be accounted for here that I'm not accounting for these first prints. But that's all stuff I can program later. That's a future me problem. How do you deal with the varying thickness of the radial lines in the print, skinny in the center and thick on the outside? So I need to do some compensation for that. I don't have any compensation. I have a version of a G-code modification program that will apply that compensation. But for this print, I just wanted to get going and printing something, so I didn't use it, just because it might, you know, throw an error halfway through the print. And I figure it's going to be better to test that out later once I've proven this mechanism a little bit more. Yeah. So running an efficient test program is, you know, it's not trivial. You have to know when to push things and when to try things out. Not bite off too much. Not bite off more than you can chew. So yeah. Really what it should be doing is scaling the extrusion based on how far in or out it is. And that's pretty trivial to do mathematically. But like actually making a program that does it reliably and doesn't cause any errors in the print, that's where the challenge is at. But you can see it's, let me zoom in, and I mean, you can probably see it just as an observer on the live stream. We've got under extrusion out here where you can see separation between the lines. Like right here, under extrusion. In here, we have over extrusion. So it's a compromise. I basically have to choose an extrusion value that, yeah. I'm going to get a little thing to knock these down a little bit. Hold on. Do you borrow from how Delta printers compensate for the round build plate? No, Delta printers have a different system altogether. Like I have a presentation on the different kinematic systems that 3D printers use. I haven't made the video about it yet. Maybe I'll make it in the next month or two. But basically a Delta printer, the kinematics they're actually really simple if you think about it systematically. But basically with a Delta printer, you pick a point and then you draw a sphere around that point, and the sphere's radius is equal to the length of your little connector rods. And let's say you pick a point in the middle, you draw a sphere, and where that sphere intersects the linear motion systems, like, draw a sphere. If it touches here, here, and here, then that's where you assign those motors to go to produce that point. And if you move over to the edge here, you redraw that sphere, and where it intersects these lines is where you assign the motors to go. So it's all geometry. It's not too complicated. And fortunately, computers are very good at repetitive geometric calculations. So yeah, anyone else have ideas of what they would like to see printed on here? I mean, heck, if you throw me a couple dollars, I can, pay for the filament and stuff. I can run some prints on here. I can open up Nathan's print shop. Continuously circular. Yeah, I have done that. Carlo C. Años. What would you call this type of printer? It's a polar printer with multiple extruders. I'll show you some example prints that I've done. So here's one where I just printed infill all the way around. And you can see you've got every color represented there. Okay, red, blue, white, and clear. They're all there. So that one was just kind of an interesting experiment. I actually threw this like a frisbee. It flies like crazy. Like, I can throw this hundreds of feet. Could you print a polar bear on the polar printer? I think I could. Let's see. I have another test print around here. I'll show you. Here's another one. So this was all printed collaboratively. So it did a full rotation with each print head printing all the way around. Jonathan verifies that this is all the colors. Yes. Continuous circle, spiral vase, and cool. Yeah, I agree. I'm going to do that soon. Floor lamp with inbuilt wireless chargers. All right. We can make it happen. Yeah, the over extrusion's getting a little out of hand here. I might have to turn it down a little bit. After it finishes this layer, I'll set it back to 100% extrusion. But if it builds up too much plastic, then you'll be smashing into things and it could damage itself. Oh wow, that's very squishy. Printing artistic pizza sounds pretty good. All right. Oh yeah, Overlord, thanks for recognizing the durability test. It was very durable, sort of. Yeah, 0.8 millimeter nozzle. I'm gonna run these soon. These 1.8 millimeter CHT nozzles. I should be able to get another 50% out of these hot ends with them. So, yeah. So these ones have that CHT inlet and a very large output for the nozzle. Yeah, that's true. I need a software compensation. I can do it. I have the code for it. I just haven't applied it yet. Just because I wanted to, I'm moving soon. So like in a couple days, I'm going to be in a different office. So I wanted to just like get something printing to get like a really big high output print test. So I think this qualifies as a high output print test. We're going to be using like 16 spools of filament. Here, you guys deserve a better view of what's going on here. So here. All right, printing away. Yes, it's running 4 tube conductions from Luke's lab. So Luke donated them to, use on this project. So that's just an awesome thing to have because they can flow a lot of filament and they're pretty durable. So you want to have some sort of high flow hot end on a machine designed for high flows. I'll be doing a hot end battle royale. I haven't really announced this yet, but I've been in contact with all of the people who make high flow hot ends right now. And they're all sending me hot ends. So I'm going to have the Mosquito Magnum. No, not the Mosquito Magnum. The Mosquito Prime from Slice Engineering. The Goliath from Vez 3D, the Tube from Luke's lab, and the Takoto from A3DP. And we're going to put one on each hot end and have them all face off in an epic battle royale. And this is the perfect test stand to demonstrate those, because I've got 4 of them printing all at the same time running identical G-code. So it'll be pretty interesting. We'll really see what the limitations are on those things. Yeah, so these fans are too strong. I need to replace them with less strong fans. Where are the PLA spools without input shaping pre-installed? I don't know what you're talking about there, but I'm coming up on having to switch out my spools here. Let's see, that red one's looking like it's getting a little low. I think it's fine. Okay. There's looking pretty low. All right. I just have to make sure I don't get in a situation where I miss the filament changes. I can always pause the print or slow it down to like 10% to give myself a little extra time to switch things over. But I think it'll be fine. All right, I'm cranking up the extrusion for this part. Oh, crap. Oh, no, never mind. I need to turn that back down. Okay. Okay, we're all good. Yeah, this trash can's gonna look sick. It's gonna look so cool. So it's not going to be a round trash can. It's actually, you can see the shape of it starting to emerge here. but it's going to be like this kind of square shape with these serrated pieces in it. It's going to be absolutely cool. All right, just doing a little manual tweaking of these. So what's the max RPM? Yeah, so the max RPM right now is about 3 rotations per second. I'm going to be putting some better servo-controlled motors on there, and they should be able to do, I don't know, like I can get this bed spinning really fast if I want to. 3 rotations per second is already fast enough. Why not combine 2 opposite rails and move the print weight? Yeah, that's true. Yeah, I was thinking about that. There's definitely a lot of improvements that can be made to this design layout. So I'm working on that. I want to get the maximum value out of this iteration before I start looking at other improvements. All right, I turned it up to 150% for these next moves. Yep. Yeah, that'll make sure I get plenty of filament down there. Yeah, so I'm basically doing the flow compensation manually right now. Like I'm just typing it in, which is not a very good way to do it, but that's what I'm doing right now. So we'll turn that up to 200. And I'll turn that down to 50. All right, so it's going to make this next pass absolutely fat to try and catch up. Yeah, that'll fix things up. So I slowed it down and turned the flow rate up to really kind of flood this area with hot plastic to clean up the extrusion. Yeah, and I think that's what I need to do for these outer layers. I really need to get that radius-based flow compensation set up on here because that's going to really improve things. Okay, and then we'll set it back to 100%. And 100%. All right. I'm going to get you right up close into the action here. So you can see this extrusion's looking super clean now because I turned down the speed and cranked up the flow rate. So that's just gonna like really clean up those bottom layers and make sure this trash can's durable for when it's finished. Are you guys getting tired of watching the red filament? Because I can switch this over to like the white or the blue. The red looks like meat. Oh, crap. All right, we'll switch over to the white side. Let's see. Get up here. Oh crap, I gotta turn that down. Yeah, I don't have the best overview of the white area. So each segment will overlap in that they're going to be spiraled over each other. So there will be a 360-degree twist. So it'll go all the way around, like the white filament will end up on the other side of the trash can halfway up. Edmonton, stop being a hater. This is a record by any stretch of the imagination. Look how fast it's going. It's the most expensive 3D printed trash can. That's the record. It's round like a record. Okay, sorry, Edmonton. No, this is this machine will be capable of over 400 cubic millimeter. Yeah, 400 cubic millimeters per second, which I don't know of any machine that can do that. That's using standard 1.75 millimeter hardware. Yeah, hold my peak. Should have named it bipolar with 2 print heads. So it would be very easy to do a 2 print head bipolar printer using a standard IDEX. So, yeah. Is Lubon a type of filament? Uh-oh. I'm mega over extruding this line. Hopefully that doesn't cause any issues. Yeah, this is way over extruded on that inner piece. That might come back to bite me. Looks like my red spool is almost out. Finished Z height, I think, is going to be 29 inches. That's the standard height of a trash can. That's why I use 29 inches. So, based on what I read, radiation shielded trash can. I like the idea. Yeah, I could do an 8 print head version. I do think 4 is the optimal number. 8, you would have to use a non-standard power outlet to draw that much power, and it just gets much more complicated to manage all that stuff. But it would offer twice the print speed in terms of flow rate. Oh, crap. Okay, red is nearing its last layer of filament on that spool. That's going to need to get changed out soon. Oh crap. I am over extruding way too much. Oh man. Okay. Oh no, there's one more layer left on that red. Okay. Dang. Okay, this is all PLA. Okay, I have to turn this down now, so down to 50%. I'm actually getting kind of worried here because I over extruded way too much on these inner layers. And it's basically like, yeah, not good. This is like a semi manual process where I'm having to dial in a bunch of the settings as it's moving along, which is a really dumb way to do it, but I just don't have the right software compensation built into the printer yet. So that's what we're dealing with. Okay. So just as a refresher, this is what we're printing. I know it doesn't make a whole lot of sense out of context, but yeah, basically this gets translated into a part using the polar printing coordinate system. And yeah, it's going to be like a spiral of 4 different colors going up the side of the trash can. All right. I'm going to trim off some of this filament over here. I know you can print in the middle, but I can't tell if the middle circle where the benchy is printed or tape. Oh no, the middle's just tape. Yeah. Printing in the middle will be in the next revision, I think. The other issue is when I get closer to the middle, it's absolutely imperative that I have the software compensation programmed in at that point. Because if I'm over extruding, basically the amount of over extrusion is the ratio between the current radius and the overall radius. And when you reach the center, you get to like some infinite, divide by 0 error, where you'll be extruding way too much and not moving. So yeah, I'm gonna wait to do center stuff for when I have more of the firmware fully fleshed on this thing. But whoever said something about a record, I could actually try printing a record like what the Prusa website was joking. They added the ability to print records that you could play. I could try that on this machine. It'd be like a massive oversized record player. Oh yeah, Sebastian has the right idea with the song that I'd have to pick for that. What if you combine two of these upside down? You could start printing the trash can from above towards the bottom as well. That would be interesting. Not the most practical, but I like the creativity there. Play it on the bed. Yeah, just leave it in place and have one of the arms. You replace one of these print heads with a record playing arm. That could work. Fisher Pros Records players. You know, actually, I could just get a record, put it on the bed, and attach a needle, and just like have it play a song while it's printing. Instead of trying to print the record, that'd be a little crazy. So here's the first print. For those of you who haven't seen it yet, it's pretty cool. Derp. What size linear rails? These are HGH series. So they have quad. Yeah, very large. Okay. So this is giving you a different view of things, hopefully. Let's get you in there. Does that look cool? Now you're rotating with the bed. So if you do the math, thanks for asking about the slicer, because you know you got to ask those nerdy questions. So if you're translating from a polar coordinate system to a Cartesian coordinate system, you can do like this. You can do matrix math. You basically do a matrix transformation to like switch it between coordinate frames. And that's what I did here. Essentially, I'm using a secant function to create a curved line in Cartesian space that turns into a straight line in polar space. Secant is like the inverse sine. Uh, it's like the sine of the inverse of uh, the sides of a triangle. I don't know. You got to take some math to figure that out. I'm not a math teacher. At least I'm not anymore. So I'll let someone else explain that. You can go to Khan Academy or something. Am I going to Rapid TCT? I think so. I've got some people that want me to film there, so I'll be sponsored to go check it out. So it should be fun. Polar space, aka the vast amounts of wilderness above the Arctic Circle. Exactly. Polar space. Mm-mm. Uh-oh. I heard a noise. I do have to worry about what happens if one of these heads is skipping steps. Oh, why is it going so slow? Come on. The one thing that this machine is vulnerable to is the USB cord that goes to the laptop. If that gets bumped, it might just kill the whole print. So I'm being careful not to bump it, but with how much I'm messing around with the slicer, or the user interface, I'm moving the laptop a lot. I just hope it doesn't mess up this print. No Octoprint yet, no. I'm just about to change a spool out. This will get a lot less complicated once it finishes the bottom layers, because when it's doing the sides, it's not going to have to transition between large radiuses and small radiuses. When it's doing just the walls, it's going to be staying to that larger radius, and I can dial in the settings to maximize speed for that. But for now, we've got to, switch things around. Yeah. All right. Well, thanks everyone for watching. I'll keep this stream going just because I know everyone wants to see this trash can. So we'll keep it running. It could be a good thing to just leave going in the background. Oh, I gotta turn the extrusion up again. Okay. These filament reels just keep on going. So I'll get them switched out eventually. Greetings, chat. What nozzle size? Nozzle size is 0.8 millimeters. I'm going to put them at 1.8 soon enough, but right now it's just 0.8. So everybody knows about the Big Tree Tech duckies, right? You get one of these with each Big Tree Tech board that you buy. Well, I've got the elusive Big Ducky. You get this one if you buy like one of their huge, expensive boards. So, Big Tree Tech. Okay. Yep, I'm making a robot. I heard enough people complain, so I was like, you know what? I'll make a robot. Why the heck not? But now I'm building a trash can. This is just fun to watch. Hey, Herzelnerk. Welcome to the stream. So I have a question for anyone that's watching. If I were to print some stuff to sell off of this machine, what would you actually buy? Would you like wall art? Step stool? You want your own version of my trash can? You want one of those? It'd be at least $50 because that's how much the filament costs, but, you know. Thick molten stream. Yes, that is what we have. Crap, I gotta turn this down. I keep accidentally over extruding in the areas where it's not supposed to. So it builds up this gigantic mound that it kind of runs into. Whoops. Can we just take a minute to appreciate how everything on this machine just works? It just frickin' works. I'm a poor Brazilian, I can buy nothing. Okay, well, you're probably not the ideal customer then, Mr. Cabral. But you can definitely watch the stream for free. It just works. Unless I bump the USB-C connector, or bump the USB connector and it kills the print, which is not a good thing, so I'm being very careful. I've clamped the cable there so that it won't get bumped, but you know, there's always the chance that it gets nudged and it cancels the print like 10 kilograms in. Yeah, it just works and it does multicolor. It just works. I hear a lot of noise. Silent of the fans mod right now. It's actually not too loud. I get that, you know, I'm not editing this or anything, and the fan just kind of, I don't know. It's not too loud though. That's just the power supply fan, and I could definitely replace it with something quieter if I needed to. Use the parts. No, I didn't use any of the parts from the A1. Those are all tainted with bamboo toxicity. You know, the toxicity that only exists in the Bamboo Lab community. You can print sleds on that. Sleds, like to go sledding. That's possible. I was thinking if I made this, if I made a version of this that was 3 times taller, I could print a kayak. Yeah, there was some difficulty building this machine. Just like little things that I had to rework. But for the most part, it all went together as planned. Now, if someone wanted to buy this, how much do you think I should sell it for? Ghostly Gnome. In the future, I have an idea for a large sculpture that I might consider. Oh, that'd be sweet. Yeah. Ghostly Gnome, if you've got sculpture ideas or furniture ideas, 3D scans of their heads, print versions encased in carbonite. Yeah. Well, the thing is, a normal head will fit on a normal 3D printer. So I would maybe have to do like a 4 times scale head to like a giant head helmet. What if you wore a helmet that was your own head? That'd be pretty sweet. Okay, now I gotta remember to not let this over extrude for this next bit. Yeah, this isn't the cleanest extrusion in the world. Quad vase mode vases to sell? Yeah, I could do that. This is a PhD in proving flat Earth. I could 3D print scale models of the flat Earth. Do you think there'd be a market for that? How many steppers did you use for Z, or are they all synced? So it's set up a lot like a Voron 2.4. It's using quad gantry bed leveling. So, yeah. I did have to do some hacky workarounds to get everything going using Clipper, but it's working well enough right now. But yeah, seriously, if anyone wants to print something on this, reach out on Discord or send me an email or something about what you want to print, and I can come up with like a quoting process and figure out how much it would cost to ship it. If you have a relative working in Brazil Central Bank, no, I don't think I have any relatives in Brazil that I know of. You never know, though. My last name's Norwegian. Skyrim belongs to the Nords. Sorry if that's a little too cringe for you guys. That joke was cringe enough that I expect to lose about 10 viewers just from that alone. Ken Tenhidi. Okay, not me. Talking to someone else. Gabrielle. Yeah, I thought about it and I was like, what does he think my last name is? It's not Builds Robots. Holy cow. This thing's really gonna start to take shape soon. You can't really tell the overall structure of it just yet, but it's gonna look awesome. Ooh. I gotta load up my last spool of filament too. Oh crap. Okay. Okay. Uh-oh. Blue, white. Blue. Okay. Blue. White. Okay, that's good. Okay. All right. All right. That should do the trick. I just had to get everything organized. So I'll swap them out and maintain like the same order from from left to right. Gray, blue. Yeah, I need a better solution for the spool management. But it's gonna have to do for now. This is gonna look a lot cooler in an hour. Yeah, I was worried about bumping the wires while I was doing all that, but everything stayed together. So that's good. You want your Voron to be this beefy? Yeah. The only reason why it has to be this beefy is I'm using cantilever arms. It could get away with being a lot less sturdy if I had, a more traditional setup. Cantilever is like inherently very weak, so you have to make up for it by making things very strong instead. Yeah, I definitely need to come up with some way to do filament changes or just get bigger spools of filament. Like, really, feeding this thing 1 kilogram spools of filament doesn't make sense. This right here, oh, that hole right there reminds me of Attack on Titan, with the muscles from the Titans. Looks like the eye hole. Slant 3D, all right. I'm gonna go through a lot of filament. I think the best way to do it is to like print useful stuff for people that they need printed and have them pay for the filament. It's probably the best route. Just because this thing can, when I get it fully running, it's going to be able to consume 50 kilograms per day, which I don't care how generous of a sponsor you want to be, spending $500, sending over $500 worth of filament every day is not going to be a sustainable relationship. Like, Polymaker enjoys sponsoring people, and they send them like a couple spools a week, maybe. For me, I would need like a pallet of spools a week. That would be like 350 kilograms or close to 800 pounds per week of filament that this thing can go through. Okay. All right, so I'm on layer 5. We're only on the 5th layer so far. I'm gonna check on here. So it looks like I'm gonna be printing solid layers up to layer 7. Layer 7 is going to be the last solid layer, and then it's going to be just printing the walls of the trash can. So that should speed up a lot when I get to that point. Looks like blue's about to run out, so I need to get ready for the filament changeover as well. Gotta turn up the extrusion multiplier now. Okay. There are 4 heater pads under the bed. Yeah, it's heated. This wouldn't work without a heated bed. Oh crap. I'm over extruding again. Oh well. Oh wow. Okay. Wow. Okay. Holy crap. Oh crap, oh crap. Okay, one down. Okay, next up will be red. Stop. Okay. God, no! Come on. Okay, so my part cooling fans are too strong. Part cooling fans triggered thermal runaway. So I'm going to restart this and try and get it going from where the G-code left off. All right. No, we're all good. We're all good. Just have to copy that G-code file, figure out where I am, and then resume without homing. I hate that. Okay. So let's see. We are at... I can just look at fan speed. And for some reason in here it says the fan won't turn on. So I'm confused. Oh, right there. Hidden inside of the frickin' model, it turns the fans on all the way for just one line of the print. So it's safe to say we probably ran out of, you know, stuff right there. So I'm going to basically figure out where that line is, delete it out, and go from there. So okay, so that's annoying, but we can fix it. All right, I'll try and check on the chat while this is all going on. So what do you think of my part cooling? It's pretty good, huh? Just got demo... Oh, am I not allowed to say bad words? Did I say a bad word? I mean, it's understandable. Okay. So, I need to figure out where it sets the fan speed. Okay. We are looking at quarter can G-code, open with text edit app. Okay, so quarter can G-code. Let's just do Control F for layer, change, 1, 2, 3, 4, 5, 6, Okay, we should be on the 5th layer. We can also look for a fan speed assignment. We're setting the Z to 9, so yeah, that's right here. So I'm just going to delete all the lines prior to this. Okay, so we're gonna home. I don't need to prime the nozzle. We'll home all axes. Oh crap. Homing Y is gonna be kind of difficult to have it be the same, because I'm just manually clicking a random point. Alright, so we'll figure out how to do it. Okay. That's all good. Go ahead and save. Okay. I'll move all the print heads back. It's going to home. I think that should be fine. And this is an annoying thing about Mac. It can't do text editing very well. Like, look at this. It's freaking out. It's like, oh my gosh, I have to edit a text file. Like, why on earth does it take a minute for it to do that? Okay, that's good. I'm going to delete any references to change a fan speed. Does anyone know the G-code command for changing fan speed? Or better yet, I can just unplug all of these fans, because they're just going to break things. I should have unplugged them to begin with, because I'm not planning on using them. Okay, alright. That's all good. Stuff happens sometimes. Quarter can, layer 5. Okay. Also, ejecting stuff takes forever. Okay, we'll get back to printing shortly here. It's going to be a little chaotic because I need to realign the bed, which I'll probably do by brute forcing it to like being where it's supposed to be. Yes, eject. Thank you. Okay. So, now we need to get back up here on our clipper interface. Alright, we've got our new G code loaded up, and I'll just run it. Okay. So, oh crap, oh yeah, I unplugged the fans, so we're not going to have an issue with that again. Alright, print. This is the weird part, like there's no Y homing, so I'll just kind of try and get it at the right spot. Alright. And we'll set the extrusion, we'll set the print heads to 260. Alright. And then I'm going to have to manhandle this bed to get it in the right orientation. Oh! I did a pretty good job lining that back up. It rotated the colors, but we'll just call it an artistic decision. We'll see how far off we are. Okay, yeah, that's kind of far off. So I need to rotate it this way a couple of clicks. Ooh, that's hot. Okay. Huh. Okay. Well, that's exciting. Okay. You know, nobody said this was going to be easy. Did you like watching me burn my hands on the bed? That must have been fun to watch. All right, I can try editing G-code on Clipper too. That sounds good. I think we're all lined up. I mean, aside from it being offset a little bit now, it kind of looks better, if you ask me. It's definitely a creative decision-making thing. It was definitely a deliberate, creative decision on purpose. Okay, so it looks like the next one that's going to need to get replaced is the red. You know, maybe I should add in some custom G-code where it just randomly rotates 90 degrees to change the colors, do a color shift. Pretty neat. Okay. I'll get this red prepared. This red stuff is a little more brittle than what I was using before, but that's fine. This is Meta PLA from, I don't remember what company. Meta PLA. Silly marketing term. Alright, so slightly different color of red now. Uh-oh, what the heck? Oh no. Looks like blue lost some steps there. Oh crap. Oh no. Ugh. Oh crap. This isn't good. Holy cow. Ah. Okay. Oh shit. Ah. Okay, let's get that all dialed in. Okay, everything's been going to crap really quickly, but we're going to get back on track. All right, we're not throwing this 4 kilograms of PLA we've already laid down away. All right, so basically I'm going to just multiply the extrusion by 300% for this next little bit here. And I'm just going to fill in all the material that I missed out on over the last, I don't know how many minutes everything was going to crap. So yeah, I'm just going to completely engulf this whole area. We're just going to backfill everything. And I did random adjustments to the z-axis, so they're all going to be at different heights now, which I'll have to reckon with later. But I think we're fine. Everything's okay. Oh, crap. Come on. Oh. All right. Whew. Okay. All right, so I think what I'll do is I'm going to grab a 3D printing pen and I'm going to try and fill in some of the areas that are missing right now before they get covered up. So, got to go fast. Oh, I'm going to disable that one for a second. It's very over extruded. Now we'll re-engage. This has turned into like a man versus machine thing. Okay, I've got a minute to read chat, so if anyone has any comments. Yep. Have to be quick. Pen is slow heating. I'm sure it's fine. With the thick extrusions, it'll bridge over. Yeah, I think it'll be fine. This gray is like foaming up, so it's like it essentially has like a huge extrusion multiplier applied to it. So I need to like have this one extrude less than the others, or turn the temperature down. I think we're all good now, though. I'm gonna take a minute to have a snack. Hooey. Do you have a news link? Looks like tie-dye printer. Yeah. All right, I'm gonna eat something. I have the Enchanted Jangle from Trader Joe's. It's limited time only, so you have to get it now. Trader Joe's. I wish it was sponsored by Trader Joe's because their snacks are delicious. Okay. So once we get to the part of the print where it's just printing the outside, this is going to get a whole lot easier. But we have 2 more layers like this that I've got to get through. 2 more solid layers. Thanks for the bit of confidence, Andrej. I hope it succeeds too. Okay. So what's oh, someone's leaving? How dare you? So the bin's going to be 29 inches tall, which is the standard height for this sort of thing. We'll keep this running until we finish this monstrosity of a trash can. There's definitely been some trials and tribulations, but I think we're gonna get through it. This is looking like a nice ricotta cheese over here. Mmm, tasty. Alright, when it finishes this up and it does a quick travel move, I'm a little concerned at what's going to happen. Oh, nothing too bad. Okay, we'll turn the extrusion multiplier back down. Ah, wow. Alright, I think I'm going to turn the temperature down on this one. It's not handling the same temperatures very well, so I'll turn it down 20 degrees. Arm 2. Best thing since sliced bread. You bet. Yeah. Your bum on that. Okay, middle name is Bamboo Lab Fanboy 69. Uh-huh. CNC maker. Well, now basically all of the print heads are not properly aligned. I don't know if any of them were spared in that last little maneuver I did. So, that's fine. Everything's just going to be a little mushed up. It'll self-correct, though. The 3D printing process is actually very forgiving. Ah. Ah, wow. To the 71 of you who have stuck with it, who've watched the stream up to this point, I congratulate you. Thank you for sticking with me. It's just this last 2 layers that are going to be like this. I think I just have one more after this. Oh, man. And then we'll be printing the sidewalls and it'll be a lot more fun. With all due respect, it's entertaining to watch others fail and struggle. After that, super entertaining to see them succeed. All right, well, we definitely got the first part of that done. Now we just got to get the second part, the succeeding part. Ah. Okay. I need to over extrude for this portion because this was missed on the last layer. So we slow down and increase the extrusion rate. That'll really fill in all that material that we forgot about last time. But yeah, I mean, it all looks good on paper. The difficult part of this is like actually doing it. This is the most hands-on print I've ever witnessed. Yeah. It's like human scale, so you can really get your hands in there and make it an interactive experience. I'd like to put some special firmware on here that would be like real-time control, so you can actually like manually change things as the printer's going along. Kind of like a manual mill or a manual lathe, but with an all-electric interface. It'd be pretty interesting, I think. Like, imagine a vase mode where you control the angle that it's laying the filament down as it's going, So you like interactively make the part. Could be fun. Okay, I think we've mostly caught up with the extrusion here, so I'll turn the flow rate down a little bit. I just really want it to fill in these areas where there's a gap right there. So I might turn the extrusion multiplier up again when we get to that point. And I'm really impressed with this bed surface. There's no peeling at all, it's just stuck. Okay. Alright, I'll leave the extrusion multiplier where it is now, and when I get to the other half of this infill, when we get into these areas, I'll have to crank it up. Maybe create some kind of variables for flow rates and movement speed. Yeah, that's a good idea. Years ago, astrophysics simulation I worked on ran its own web browser that exposed certain variables so they could be manually changed. Hey Nathan, sorry I just joined in. This is an extremely interesting printer, and it's amazing how quickly you threw it together since your video announcing the idea a few weeks ago. Very nice work. Yeah, I've been working a lot on this thing. Working a lot on it. Okay, so yeah, we're just gonna let it go for a little while. I don't really need to do anything here. I really need to do the flow compensation that I have programmed already. I just need to, you know, process the G code and get it working. It might be a good before and after to print this now without flow compensation and show, like, you know, all the manual workarounds and stuff I'm having to do, versus when I get the flow compensation going, I'll be able to just let this thing print, and if it's tuned properly, it should just be able to go the whole time. All right, things are slowing down a little bit, so I'll read the chat and see what's going on. The space in the middle could heat a pizza and keep it warm. That's true. Very, very true. 4 3D in 1 swag. Hello, Teatgen Engineering. You like coming to live streams, I know. You've got a nice profile picture of some sort of lattice, too, so very nice. What are the major issues I'm having? The main issue is this printer does not change the amount of extrusion that it makes in relation to the center of the bed. Function is when it's in the middle of the bed, it extrudes less because for a given Y rotation, there's just not as much material to lay down. But when you move to the edge of the bed, it needs to extrude more for the same Y rotation. So it's just a little calibration that I need to do. I have the code. I just need to process it. And if anything, running this test print has really demonstrated how important that is to have that flow compensation. Teatgen, I disagree. Lattice structures are overrated. There's certain applications where they make a lot of sense, but this philosophy of people applying them to everything is not good. Not good at all. In my humble opinion. I apologize if that offends you. Okay, so up here I'm going to move these back. So I moved these two back that way. 3 clicks. So that way it's going to over extrude in the area where there's not enough filament. So, yeah. Learning all sorts of tricks on how to get this to work correctly. And just for reference, right now we're printing... Oh, no, we're going pretty slow. We're only doing 29 cubic millimeters per second. We can turn that up. Nice, it's filling in those gaps. Now we're going 41 cubic millimeters per second. And I believe this, let's see. We're on layer 6. There's one more layer to go of solid printing. And then it's going to speed up dramatically. So, yeah. Yeah, layer 7 is the last layer of single, of having like a large base to be laying down. Holy cow. All right, let's see. Very offensive. Sorry, Teatgen. How much PLA will it need in your estimate? So I think this is going to use about 16 kilograms. I don't know the exact number because I have to adjust the flow multiplier. So Austin asking about the Perfect First Layer podcast. I stepped down from that to spend more time working on this. Basically, is what it comes down to, and I have like some sponsors that need X number of videos per month, so I'm like kind of running low on time. So yeah. What's up with the extrusions? Looks very janky. What looks janky about it? You mean like the quality of the plastic that's being laid down? Yeah, I'll give you that. It does look pretty janky. Each head has its own power supply. Yeah, they're all running on the same power supply, but they each have their own power cord and data line. So yeah, this is the last layer. Oh my goodness, that's a lot of plastic. This is the last layer before we get to just walls, and the walls are going to go a lot faster. Should go about 10 times faster per layer once I get to that point. Printing away. Da, 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 da. Anybody done the math how long this print would take on a normal printer? Yeah, someone should do the math. How long would it take to print 14 kilograms? It's going to take 12 to 16 kilograms of filament to build this trash can. So, how long does it take to do 14 kilograms? We'll just go with the average between those two. So I'm speeding it up and slowing it down and modifying the flow multiplier as I'm printing this to get everything to line up as it should. And yeah, it's not great having to do this manually because it leaves open a lot of room for user error. I've made a lot of mistakes. I'll be the first to admit that. Three is looking good. 260. Ah. And this is the last one before walls. Yes, that is correct. If you could print in TPU, what would you make with this printer? Is a good question. Oh no. No. Uh-oh. Okay. Yeah, it looks like it's in the right spot. It's just catching on stuff. Um, the flow multiplier needs to change based on the distance from the center, and I'm not doing that right now. So it's causing all sorts of issues. Oh, what? No, no, no. This isn't the type of machine you can just leave running on its own. Whew. Yeah, just like that, Nuno. Just like that. It ends up over extruding as I move to the middle. But yeah, I have a G-code modifier. Basically, it uses the X coordinate to scale the feed rate and extrusion multiplier. But I have to box this thing up like basically tonight and move it. So I just wanted to get some tests done, and I thought that it might be a good idea to try it without the flow fixing code. And that might not be a good idea, but this is just what I'm doing right now, so there's that. Wow. That filament is like clay when it first comes out. You can just like squish it, move it out of the way. Oh, yeah, demons, I will, yeah. Yep, there's lots of things that need to be addressed. But we're just trying stuff, okay? We're just trying stuff. And this is a good stress test. You know, when I get printers in for review, I'm pretty rough on them because I want to see where they break. Likewise with this machine, if one of these brackets that's holding things together isn't strong enough to handle a collision, then it needs to be redesigned. So I'm exposing the weaknesses right now. Oh, that's hot. All right, this thing's gonna be sturdy enough to crush someone's skull when we're done with this. Oh yes, merry-go-round music. That'd be lovely. I need to find some copyright-free merry-go-round music to go with this live stream. Thank you, Nuno, for seeing the positive perspective here. This, I do consider this print a success, despite, you know, all the wacky stuff that's going on. This is nowhere near what I'd want to have it like as its final state, but just in terms of slapping together the mechanism, having it crash and go through all these use cases, I think it's doing pretty well. Okay. I could definitely use some closed loop steppers too to catch these skips. All right, we'll turn the flow down a little bit. Turn the speed up. Let's celebrate. Woo, Dropkick Demon, thank you. You need some filament for printing at 2 kg an hour. Love your reviews and love this machine. Thank you, Dropkick Demon. That'd be great if I could earn enough in donations to cover the cost of filament. That'd be pretty, let's see, I would need to be making $20 an hour. Maybe this will be just like a live streaming machine where I just keep it running on live stream, printing constantly, and see if it can self-fund itself. Perpetual filament eater. Alright, and then I'll increase the flow one more time for the last bit of infill that we're going to be doing for the whole print. Now, after that, we're just going to be doing perimeters. Alright, turn up the flow for this. All right, so so for those of you who've been with the stream from the beginning, what's been your favorite part so far? Was it the filament change out? The part cooling fans killing the printer temporarily? The G-code explanations, filament change? Yeah, that was pretty hectic. I need to plan ahead a little bit for the next one so I don't end up in the same situation. All right, so this is just absolutely dumping filament. I'll give you a close-up. When I said this printer just works. Yeah. Yeah. It's not quite at the it just works phase yet, but, you know, we're uncovering the weak spots and figuring stuff out. Part cooling is way too strong right now. The challenge with part cooling is it increases the power consumption of your entire system because it causes your heated bed to work harder and your print heads to work harder. So, yeah. That's a bit of an issue at times. I can't wait till we get to the, we finish this last bit of infill, and then it's just going to be the outer walls and the perimeters. And I should be able to tune it much better, because the difference between the minimum radius and the maximum radius is much smaller. So usually you want to tune it for like being good right in the middle. And yeah, I'm hoping it'll work a lot better when we get there. The fans are 20 watt, 20 volt 6 amp, or 0.6 amp. So about 18 watts each. 15 watts. Yeah, they're server fans. I have some replacements that I'm going to install. Let's see. I have some replacement fans that are going to go in their place, and they're throttleable. These ones only go 0 or 100, and 100 is like way too strong because it just blows on the hot ends. Even though they're not blowing directly at the hot end, just the peripheral airflow is enough to just cool them off. So I could install larger heaters in all the hot ends, and design ducts that are a little bit better at not blowing on the actual hot part. But that all takes time. I think for now the better solution is to just go with smaller fans. The advantage of this thing is that it doesn't require a whole lot of part cooling, because instead of depositing all the filament in one area that has to cool off, it's depositing it in all four areas all spread out. So everything cools off much faster for the flow rate that it's doing. Yes. I am a little concerned about these seams being weak points in the print. Having your account difference rotation millimeter per second going from inside to outside. So it doesn't account for that right now. I have some code written. I just haven't applied it yet. But the next print that I do, I'll use that code, and it should be significantly easier to get prints to work right. And it'll scale the extrusion rate and the print head speed, so it'll just be a lot easier to use overall. I mean, this thing's not gonna be a finished product overnight. I'm steadily adding capabilities to it, and I want to continue to do these kind of print tests while I'm going, because you learn a lot by doing these type of print tests. All right, that was the last solid infill layer. Now we're just doing perimeters. So I need to make sure everything's all aligned here. Alignment's going to be a lot more important for this phase of the print. So I'll keep an eye on it. Oh wow, this white one is about too far inboard. Blue one might need to go out one. Okay. Oh yeah. Right now we're going 60 cubic millimeters per second per print head. So that's 240 combined. Still needs to go back a little bit. This one needs to go in a little bit. Um, okay. Okay. Turn down the flow. Do 140. Okay. Okay. All right, we still got 80 people in the chat. This is awesome. Might be overkill, but maybe a battery powered slash butane soldering iron would help to push down the hot spots on the fly. Yeah, that would be a good idea. Just like add a roller wheel on somewhere. Oh, geez, we had some skip steps. Oh, no. Okay, so this definitely skips steps. Ah. Okay, that one should be fitting in. Ah. Okay, 3D print a full-size tire out of TPU. I can do that. 68 people looking at a guy looking at a 3D printer. Yeah. Yeah, it needs like a 5mm Z-hop. The thing is that even if it has Z-hop, if it's over extruding in certain areas, it's never going to do the right thing. So I need to add that extruder compensation, and I'm just gonna run it like this for a while and hope that things even out. This red one's been up, like, doing great. The other ones are not performing as well. Ah, no. That needs to be much further inwards. Mm-hmm. Alright, I'm still waiting for everything to normalize out. Yeah, this is really illustrating how important the that extrusion compensation is. I thought it would, it'd be okay to just have it be a little bit off, but with the amounts of filament involved with these prints, if it starts stacking up in areas, it just breaks down everything. The machine just stops working. So emphasizes the importance of having that compensation built in. Ah, whew. All right, anyone? Print just finished. Dropkick Demons finishing prints out there. Meanwhile, I'm still working on the same one 4 hours later. Just heard some noises. That's not good. Noises are almost universally a bad thing. Try this. This gray one keeps over extruding. I'm not sure if there's just a huge buildup of material, so it's just a little bit higher than the other ones. But it, like, almost it continuously has problems with over extruding. Maybe the filament is foaming up a little bit. I think I need to turn the temperatures down to prevent bubbling. Seems like most of my issues are from bubbling. Hmm. Oh man, it's been 4 hours. You could skip layers if one head's over extruding. Yeah, I've been trying to skip layers in or areas of a layer. Yeah, I need to get some better firmware on here. I have the code, I just haven't put it on there yet because I'm lazy. That's and I just kind of wanted to see what would happen if I ran it like this. So it definitely motivates getting that code installed and working. Well, I'll just let it print. Like it's evening out. So the problem is that on the first layers I had a bunch of unevenness, and now that I'm kind of plowing through that and getting past that initial unevenness, um, I can just let it run and hopefully it reaches a steady state of printing in a pretty stable way. This kind of looks like a companion cube, though. So I guess I could do some life-size companion cubes as a merch thing. Just think about it, like a 20-kilogram companion cube, heavy enough to push down a button in your absence, and durable enough to throw across the room and through portals. All right. Hmm. I mean, to me, it looks like this white one is extruding a lot more than these other ones. These ones are all like dribbly over here. And the white one isn't. I wonder if the white filament is like slightly thicker. So I guess like loading all 4 of them with the exact same brand or tolerance would be important. Mm. 177, 176, 176, 177. Okay. I can't blame all my problems on Creality like I normally do, so the hyper PLA seems to be within tolerance. Color ants messing with our filaments. Color ants will... Oh, the color ants. Hello, Ivan Ra. Color ants will change the filament performance. White filament usually needs more temp than the others. Okay. Dang. Well, this will be a really dramatic comparison once I get the radius compensation set up, the extrusion compensation. Like, you're gonna see it go from like just not being able to get the extrusion rate ever to hopefully perfect prints, or as close as I can get to that. Someone skipped steps. Was it the right one? Okay. Yeah, that's crazy. The best I can do is get it so that on the inside radius it's not over extruding, and then on the outside radius have it under extrude. Just because over extrusion is going to cause a lot more issues than under extrusion. So under extrusion it is. Did not followed previous build series. So essentially there's 4 separate print. Yeah, each running its own model. Yep, this is the whole printer. I should have just stuck with a round trash can. That would have made this so much easier, and it all probably would have worked out just fine. But I decided to push it and go for a non-round object. And then I have to account for the difference in extrusion rates for the inside and the outside. And then I got myself into all sorts of trouble. Mm. So red's looking pretty good, blue's looking pretty good. Gray has some lingering issues that I'm trying to work out. I can't tell what's going on with the white filament at all. Like, I just can't see the details on it, so I don't know if it's doing well or not. It looks like it's over extruding everywhere, which doesn't make any sense. Makes no sense at all. I'm going to get on the other side to better observe it. Okay, what's going on with the white filament over here? Huh. Oh, okay. Ah, I see what's going on. So it's picking up off the back of the build surface. It's coming unstuck. So I need to flatten that out somehow. No. Okay. I got this. I know a solution. Okay. Ow! Ooh! Ouch! Hot end's hot. Okay. Alright, I got a zip tie holding that down for now. Okay. So I think we've kind of reached steady state here. So at this point I can just turn up the speeds because it's not crashing into anything anymore. So let's just increase the temperature to 250, 260. And then increase the speed. All right, now we're doing 77 cubic millimeters per second per head. I think I can bump the flow up just a little bit more too. All right, we're doing 86 cubic millimeters per second per head. I'm gonna bump the temperature even more. We can do 280. And we'll increase the flow. All right, we're doing 93 cubic millimeters per second, but you know, it's not really clean extrusion. Yeah, so we'll slow it down a bit. 73. Maybe 73 is going to be the magic number. So what I discovered from laying down back there is that corner has a bit of an updraft coming through. So, you know, all this heat is causing an updraft coming up from the bed, but it seems like the air is being pulled down. There's like a convection pulling cool air down, and it's grazing against this part of the print. Yeah, and to make sure this print doesn't end up looking like crap, I'm going to slow it down a little more. Make sure we're getting adequate meltage. So 60 cubic millimeters per second, I think, is about the limit for acceptable results. I don't really like this really stringy, like silly string type extrusion. I think you get the best results at 40, but we'll let the extrusion catch up here and see how it looks. All right, we're doing 60 millimeters cubed per second. I think it's looking okay. All right. Whoop-de-doo. All right, I'll catch up with the comments. Thanks everyone for watching. Okay, answer is 42. No Z heights. They are independent on Z plus also in out, so better than IDEX. Well, they are. I mean, it's just a different version of an IDEX. All IDEX means is independent dual extruders. Really, this is an IQEX, independent quad extruders, but who's counting? So I actually never saw the Theta printer until I had already designed this, and I shared some pictures of it online. And people are like, "Oh, I've always wanted to build a Theta," and I'm like, "What is that?" But the Theta is like a concept someone made about 10 years ago. Well, IDEX just means independent dual extruder, so I don't think it implies that it shares any axes. But the most common implementation usually shares an X and a Z axis, or yeah, shares the Y and Z coordination. Yeah, so printing different models at the same time isn't possible on this. If I changed it to be quad SCARA arms, I could do that on this if I wanted to. But I'm not going to because that's just expensive and it's a bunch more parts. So now you can start to see the spiral pattern that I built into this when I sliced it. You see the angle there? Derp. Yeah, Bamboo Lab. That'd be funny if Bamboo Lab copied me. Makes the A1 rotary printer. They did have a patent application for a type of rotary printer. I think that's very forward thinking of them to look at Polar as a concept because Polar is, it's like it's just a really good motion system. Rotary axes are always cheaper and more precise than linear axes. Well, I don't know about always, but generally speaking, I like them more. But yeah, over here you can see the 45-degree angle. It's gonna they're gonna spiral around in the when this is all done. Yeah, SCARA is just an arm with an elbow, essentially. Usually with SCARA you have it move in X, Y, and then it moves up and down in Z. OMG Frankie, I think it's not frozen. It's a polar axis or something. Yes, it's polar. Looks like I need to up the extrusion multiplier, so let me just do that here. Now we're going 66 millimeters per second, millimeters cubed per second. See, I told you to pick up when we got to the walls. Oh man, it's really pulling on that. I just applied some lube to my my spool holder there, so everything slides around a little bit easier. Okay. I think I need to slow down a little bit here. We'll go back down to 53 cubic millimeters per second per print head. We're already up at 280 C, so that's hotter than you generally want to go for PLA, but at these high flow rates, it's helping cool itself off. Oh my, that's a lot of foam. Yeah, that's one reason why you don't want 280, because it foams up like crazy. Yeah, I'll turn the temperatures down. No need to be in a hurry here. Just pop in the little bubbles. It's like little bubble wrap. It like prints little packing peanuts essentially. Okay, what's going on in the chat? Oh good, just restarted the stream. I heard the voice, the video is still going. Well, back to seeing magic again. Nice. I tend to think of IDEX independent dual extruder X-axis, so I would call Nathan's ICORES. For independent quad, independent radius, extruder Z-axis. You do you, man. Call it whatever you want to call it. How heavy will it be? The total print is going to be, based on what I'm doing right now, it's going to be 150% the weight of, it's going to be 150% times, I got to do math. It's going to be about 20 kilograms. This is just a final print that I'm doing to use up all of my spare filament that I have. So yeah, I'll just have a gigantic trash bin box thing instead of all these spools of filament. I wish it wasn't doing all these travel moves. I definitely could have optimized the G-code a little bit. But it looks cool, seeing the bed spin like this. It does do Z hops. All right. When's the move date? I'm moving in like a couple days. Free Creality sponsor there on that box on the floor. Oh yeah. Yeah, there you go. Now, what would be even cooler is if I picked up both of these 3D printing pens and was like adding more filament onto it while it's printing. I'm just going like this with the 3D printing pens. Then it'd be a 6-axis. With human collaboration. So this Creality Hyper Series filament tends to um, foam at a lower temperature than this Meta PLA. So really I should set the temperatures of each print head separately, but I'm too lazy to do that right now. Do you guys like watching the rotary axis spin? I think that's probably my favorite part here. I don't have any recommendations for 3D printing pens. I'd rather 3D print with a knot pen, like a 3D printer. I'm sure the new space will have as much crap on the floor as this one does. Yep. Give it a couple minutes for me to get all the crap on the floor. I actually don't have a place planned yet. I'm just going to be moving into my apartment, and then I need to figure out what I'm going to do for an office space. uh, I'm going to have to redo this print with my flow compensation code added. I hope it makes a difference. I mean, Know Your Joe's asking what 3D printer to start with these days. I think this is a pretty good starter printer if you want to, you know, just something basic to get started with. Can do a little bit of everything. All right, I'm going to zoom out to give you guys a sense of scale here because I feel like it's easy to forget how big this thing is. Well, I can't zoom out anymore. That sucks. Here we go. There we go. Maybe down here. It's big. Printer big. Printer big printer. This thing's huge. Look at it. Hold on, let me put the benchy back. I'm not sure where my benchy went. Here's AirPods. Benchy. Plenty of great starter printers these days. Oh yeah, filament's pretty cheap here. So demons, I tried. I mean, just trust me, I tried to get the Polar working. The firmware isn't well developed for this exact use case. Basically, if you try to do Polar, you can't do IDEX because nobody's written Polar IDEX code for Clipper as of now. But, you know, maybe someone can write it for this, or maybe I'll write it for this. It's just a matter of getting the code written. I just hope this trash can is strong enough when it's done. Alright. I think I have to turn the temperature down for this Hyper PLA. It foams way too easily. How many? I literally just got my 8 kilograms of Elegoo Rapid Plus for 140. Yeah, Elegoo makes some good filament. I just get whatever's cheapest. Usually I can get most filaments for $10 to $15. So I should be going through, I've gone through one spool, or, I'll be going through a couple more spools. I think it should be 4 spools total. I'm about halfway through this this second reload that I put on there. Have you thought of doing a video on upgrading or converting a K1 to a better alternative? Yeah, so I have a K1 Max that I want to put some upgrades into. Okay, I'm gonna turn the flow rate down a little bit. 140. Turn the speed up. Uh-oh. The blue corner is lifting now too. This whole back area is getting like a downdraft, so it's causing all sorts of problems. We'll throw another zip tie on it. Oh, shoot. The drill bit just broke. Not sure why that happened. Gosh. Hmm. Holy cow. That'll do the trick. I think I need to do that on all 4 sides. Just put a bolt in it. Okay. Oh no. Okay. 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 All right. Nick T. Nick T. Get him out of here. Get him out of here. He's going on timeout for 5 minutes. Haters not allowed. um, yeah, I'm gonna put. Really, what I need is an enclosure. So I just need to enclose it. That's all. DIY trash can kits. Yeah. All right, so it's going pretty good so far. This is the point of testing. You figure out what all the weak points are, and you just kind of scrappily get everything done. I think what I'm finding is that the bed adhesion is a real issue. It's not even the bed adhesion that's causing the failure. It's the tape is coming loose from the steel or the aluminum base. So the blue painter's tape is the weak point. And I don't mind putting screws in there. I think that's actually a really good solution. Is there a video? I mean, this is the video. You're watching it right now. Thank you, OMG Frankie. You know what, OMG Frankie? Since you're a positive person, you're now a moderator. You've been promoted. Yeah, so I haven't made a video about it yet. I've got a lot of footage of me putting it together, like time lapses and doing initial tests. Ooh, Uncle Jesse has joined the chat. Hi, Uncle Jesse. Well, it's basically a polar printer, but it's repeating the same thing 4 times. Also, I missed a super chat. Let me go back to that. All super chats go towards the filament budget for this machine. Boom. Dropkick Demon, another 5. Wow. That's awesome. I'm not going to lose an arm to this. I can overpower it. You never create a machine more powerful than yourself. Because it might go rogue. All right. All positive persons. TNX, you're also now a moderator. TNX gets it. We've got the benchy in the middle for scale and to just keep an eye on things. So yeah, I mean, I don't think it'd be unreasonable to have the slicer automatically put holes in the part for me to put screws in. And just have like a matrix of screws down at the bottom to just secure things, because when you print really big stuff, you're always going to have issues with bed adhesion. And these bolts are really holding down the fort. Oh, yeah, so there's... I can give you a peek under there, but basically there's holes, there's gaps in between the pads, and I put additional screw holes down there so that I'd be able to do exactly this. I kind of foresaw this being an issue. Um, so hopefully the extrusion gets all cleaned up. That liftage, you know, it's not great. I can actually see the plastic being strong enough to pull those aluminum threads out of the base plate. And it'll go like bang, you know, like release a loud noise. Yeah, the K1 Max is just okay. It's not great at all. Um, I've got mine over there. It's gonna get some upgrades just because, you know, it has creality issues. Okay, let's see. Things are catching up now. Yay, know your Joe. The definitive source. Yeah, things should be smoothing out now. The trash can is like getting pulled over sideways towards the other trash can that I'm printing. K1 a dumpster enclosure? I haven't heard of that. But it might fit inside of that. I think it's a little bit too big. So I think I can up the print speeds once things even out. I think those bolts will do a good job of holding everything in place. This is my point of view when I stand over the printer. This is what I see. The This new trash can will be able to hold significantly more trash than my old one. Gross. I had some nasty skipped layers there. I was just skipping a couple steps there to get it all realigned. Okay, time to start thinking about the next spools of filament to throw on there. What? gray. I guess I have a little more red. I don't really want to use that though. And I've got blue somewhere. All right, I won't be able to keep printing in red because that's the last of my red filament. So what color should I switch it to? I will take recommendations in the chat. So I have black, I think. 3D Tech. Can I buy that printer? I could sell you one. It's not going to be cheap though. Lots of the parts on there were very expensive. But yeah, I could definitely, make a couple more if you're interested. Or if you just want me to print stuff off of it, if you just, like pay me per kilogram or something, I can make something happen. But yeah, I've got some software improvements in the works. I have to think more about the bed adhesion. I think that's going to be an issue on here. That'll plague me for a while. Until I get a solution figured out for it. Red touching black like a spooky snake. Okay. I'll see if I have black. Oh, I do have black. I definitely have black. I have this. The leftover from my first trash can. So I guess I'll use that. I think there's slightly more than a kilogram left on the spool, so that will do the trick. I don't think it'll fit in here though. I'll have to figure something out for this. Got more blue. I've got Galaxy Black. I guess I'll switch the red to Galaxy Black. And let's see. I also have Persimmon. Oh. I also have Persimmon Galaxy Black. That'll do. All right, we're on layer 45 out of 410. So a little over 10% of the way there in terms of layers, but if you can recall, the OGs of the live stream will remember. You'll remember that the bottom layers took the most time. Okay, so it looks like the extrusion has caught up. Since I bolted the thing down, it needed a little more extra extrusion to get caught up, but now it's caught up. So we're going to turn the extrusion multiplier back down to 135, and we can turn the speed up a little bit. To 135%. Okay. And there you go. It's just going to print for a while now. Okay. Kip Duron, I won't block you. I will say your conduct is inappropriate, but you're staying positive, so we'll let it be good. So mix it up and don't use the same color on the same head, so it'll be nice and colorful. Yeah, I can see that. But it'll be like too random, I think. He has to mount the filaments higher as the print grows taller. Oh, that's a good point, yeah. I mean, ideally I'd have it attached to the printer up top. Up there. But, yeah. That's a problem I'm going to have to solve eventually, isn't it? I can't just ignore it. Okay, well, I'll come up with something. Let's see. I know. This is what we'll do. Oh, there's more colors in here too. I have wood fill PLA. I have white PLA, white matte PLA from the company that shall not be named. Polyterra prints like garbage, so I don't want to risk ruining this print by running Polyterra. Tech Bears. This is just good, cheap filament, black. This is the first spool of PLA I ever bought. This is like 10 years old. And I ran some prints with it last year. It still works great. Maybe I should throw it in here just as a tribute. Yeah, we'll do that. I don't know what happened there. There we go. That'll stay put now. Just had to put a 35-pound weight in there. Okay, so I think we're all set for the rest of the build. We lost a lot of momentum there with the outage. I know you guys have the attention span of a housefly, so when the video feed goes out, you just all scatter. But but I'm still printing. We'll keep this going for another while. Now, if I sliced this better, and I didn't have those little like pockets that it needed to go back and fill, this would all be printing a lot faster. But unfortunately, I did not optimize the G-code before hitting send. So it is what it is. But let's speed things up a little bit. Increase the flow. Increase the temperatures. Increase the speeds. So the flows are topping out around 87 cubic millimeters per second with the current settings, which is fast. 87 times 4. That's, roughly in the right speed. All right, so it looks like the red's gonna run out first. This is, I might as well use up the PLA I have. Like these little bits I'm never gonna use on anything else. I got these 2 red PLAs, I'll just throw them in there. I'm a little worried I'm not getting sufficient melting to get good layer adhesion, so I'm going to keep an eye on that. Now we're good. We're good. Yeah, probably need to slow down just a little bit. just to make sure I get good flow here. I mean, look how much time it's wasting on these little moves here. It's not really laying plastic down. Like, this all could have been way faster. Have you connected this meter to this yet? How much power are you pulling? The max power draw is around 15 amps. The most that you'll like typically it's probably drawing about so yeah, like 1800 watts max draw. Let me look at the powers for the heaters. Yeah, about 50% on the heaters. And on the bed, it turns on and off. So let me think about that. The bed's probably on a quarter duty cycle. And the heaters are on about half duty cycle. And all the stepper motors added up. I'd say it's probably drawing about 350 watts. That's not too bad. The bed doesn't lose a lot of heat because it's just one bed and it doesn't really move that much. Spaceballs, the 3D printer. We're going plaid. Yep, that's right. You could do multicolor printing by just rotating 90 degrees in between materials or colors. I mean, it's a tool changer almost, but all the tools can be active at the same time. I think the whole concept of a tool changer is a flawed printer design because you're like this has as many extruders and hot ends as a Prusa XL, but it can print 4 times as fast in a collaborative mode. So maybe that's something Prusa could work on, or maybe Bamboo Lab is going to work on. I don't know. Look at that swirly pattern. It's really showing off now. Nice that you're doing a live stream. Thanks, Weaselbox. Hey, we have 77 viewers again. You guys didn't leave permanently after the internet went out. Yeah, it doesn't draw a whole lot of power. That's the nice thing about it. One bed has less surface area than 4 small beds. And on like a bed slinger, you're like waving the printer around through the air. Versus this is just slowly rotating. It's not dissipating that much heat. Plus I could insulate it. Like I could get the steady state power consumption of this down to like pretty low. I'm starting to see some smoke come out of the hot ends, so I'm going to turn my air filter on. Oh, we got a question there. Frankie, if you have already done so, smash the like button. It does nothing but good. Thank you, Frankie. Your motivation has encouraged at least one person to smash the like button. So, yeah, it's not that tall yet. Honestly, it's going a little slower than I was expecting just because I've had a lot of issues cropping up. All these things I'm having to figure out what to do. So yeah, it's not trivial getting something like this to print. There's all sorts of little issues, and my G code is all messed up. Like it should be printing 2 to 3 times faster, but I've got all these tiny little travel moves, and it moves over there and prints a little bit, and then moves and prints a little more. So the actual like time it spends extruding is only about 70% of the time. So I could easily get it to be 50% faster. Like, look at all this wasted time. I need to optimize my G code. And then I had issues with the bed peeling up, but I bolted everything in place now, so it should be good. So I've got a list of things to work on. I need an enclosure. I need to change my part cooling fans to be smaller. I should probably standardize the hole pattern in the bottom so I can bolt this thing down whenever I need to. I need to put a higher resolution stepper motor in. I need to reposition the electronics. I need to get my software so it compensates for extrusion based on printing radius. Print method is impressive, I'll give you that. Thank you. So Edmonton 3D Prints, I will show you the custom G code that I'm running. Yeah, I'm running Prusa Slicer with a highly modified CAD file that's designed in 3D space such that when I print it on the Polar printer, it translates into something that makes sense. I know this all sounds very mysterious, but let me just show you the CAD model. So, do you know what a secant line is? A secant. So this is the print. This is the whole thing I'm printing. But I sliced it up into just 1/4. So each print head will be printing this, essentially. And when it prints it, it will be using 3.2 kilograms of filament. Assuming this is PTG, it's actually PLA, but the density is pretty similar. So 3.2 kilograms, and I'm currently printing it with a flow multiplier of 160%. So 3.26 times 3.26 times 1.6. That's a little over 5 kilograms per print head. So this altogether is going to be over 20 kilograms when it's done. Minus any under extrusion that's going on. When you're printing at really high extrusion rates, usually there's a little bit of slip in the extruders. So you might have rotated the extruder enough to pull through a full kilogram, but really you've only pulled through 800 grams. So, yeah. Oh crap, sorry. I need to check my Discord. Someone's coming to pick up this SVO 8. Yeah, getting rid of this over there. No, I like it. It's just I don't really need it. You know what I mean? I mean, the build quality isn't amazing on this SV08. Like, it's kind of plasticky and thin aluminum. Like, they definitely designed it to a price point. But, hold on. But the difference between, like, say, Soval and Creality is that Creality made something that looks nice that doesn't work very well. It's got great build quality, but like the actual function isn't great. Soval made it's not the best in terms of, you know, build quality, but it works versus something with high build quality that doesn't work. Uh, yeah. Okay. I'm just taking care of some business. I've been on this live stream all day. Edmonton, keep going. I'm off to make stuff. All right. Have fun making stuff. And I will keep going. I was thinking of an SV08 for next printer, but may just build a Voron instead. Yeah, I guess you can get a Voron for about the same price that's one size smaller. And I don't know which one's better. Like, I haven't used a Voron before. I think Vorons have a more sturdy build, but they're more expensive and heavier, so there's still no such thing as the perfect printer. So, is this exciting or what? Always nice to cheer on it. Woo, big. Voron's big bucks, but nice. Yeah, they're kind of expensive. All right, printing away. You could make a printer like this that only used 4 stepper motors. Technically, you could do a 4 stepper motor version of this. You'd have to be insane to think that's a good idea, but you could do it. All right, so is this print getting more or less exciting the further along it's going? I think it's getting more exciting. I hope it's like strong enough once it's finished, because it'd be a shame if it just broke. I'm printing a trash can. And I'm using a trash can as a spool holder to print a trash can. Yeah, it'll look like a trash can when it's done. That's the idea, at least. So yeah, I need to make a lot of improvements to this thing. And I've got enough parts to make a second one, so I might build 2 of these. But then the question is, what do I do with the first one? Or do I just run 2 of them at a time? Max build height right now that I've tested is 800. I might be able to go a little higher. Yeah. Here's the other trash can. This one's a lot cleaner though. This was printed on CRM4. I mean, people hate on Creality, but that CRM4 is a good printer. Look at that. Look at that consistent layer lines. That's insane. Yeah, I mean, people online, they hate that I printed this trash can. It's like, it's awesome. Why wouldn't you want to print a trash can like this? This thing's cool. I use it for all sorts of things, like, you know, look at this. It has trash in it, first off, which is, you know, what it's supposed to do. But look at this. Look at this. Trash can. Trash can. Very sturdy trash can. Can you stand on your trash can, Woody? Post a short video of you standing on the trash can. Yeah. If you can't stand on it, I call it a trash can't. I hate that I have this wasted time with all these little infill G-code things that it's doing. It's an absolute waste of time. So yeah, I didn't switch over to my 1.8 millimeter nozzles. Those would definitely be able to print this um, at least 20% faster. And also that little bits of G code where it like prints tiny little infill segments. That's also a little wasted time that I could reduce. So I'm not hitting the overall print speed that I wanted to for this thing, but I'm just gonna let it print because it's gonna be a cool thing to have regardless. Oh, did I haven't shown this in a while. To anyone new to the stream that hasn't seen this test print, what do you think of that? .3D printing basket weaving. Strong parts. I also printed this. That shows the pretty much the full build area. Yeah. Trust me, if I got into the airless basketball game, I would be I'd be able to make a better airless basketball. I could 3D print a car. Yes, I could. I could 3D print a car with this printer right here. If anyone wants to see that, maybe I need to start like a GoFundMe, because that's not going to be an inexpensive endeavor. I bet I could make a 3D printed car for about $2,000. That'd be able to drive like 35 miles an hour. All right, let's see how things are going here. We're pushing 73 millimeters cubed per second. Unfortunately, that's not a continuous 73 cubic millimeters because of all this like stupid little wasted time because my G code sucks. And I also need to make sure the bed adhesion is good, and I mean, there's a lot of improvements I need to make here. But this is how we learn. Three-stage rocket. Would the car be running on geared NEMA 23 motors? Maybe. NEMA 27s. I mean, if you did stepper motors, you could do do omni wheels or something, so you could drive left and right and diagonally and spin in place. How much did this printer cost you to make? What's it to you, squarish link? I'll just say it was expensive. Yeah. At least 4 times what a normal printer would cost. Squarish Link, you're a good estimator. I'll give you that. Do. There it goes. I'm gonna revisit this. You know, we'll get everything working way better and do the same print over again, and I bet I can do it in half the time. This is just taking too long with all those travel moves, and Very disappointing. I don't think it needs some lube. What do you mean? What part of it needs lube? Yeah. Speaking of lube, I got wax all on the inside of this spool holder now. Alright, there we go. Now you can have a little spool up close to give you some perspective on how fast it spins. This is 73.6 cubic millimeters per second. That's about twice as fast as a high flow Bamboo Lab hot end. And there's 4 of them, so it's 8 times faster than what you'd get on a, one of those POSs from that company that I don't like. The travels are probably just honking due to resonance. Yeah. Yeah, it's the stepper motor having a little bit of resonance. I'll get a better stepper motor on there, and that should help address that. I'm basically running like a super cheap, really powerful stepper motor on there, and I think something that's like a little nicer would probably benefit me quite a bit. Man, these travel moves are really driving me crazy. It does make it look more interesting though. So when it comes to 3D printing large stuff, I thought of making a hot end with a very wide diameter. Yeah, I have some 1.8 millimeter diameter hot ends that I'll install eventually, but right now I'm running 0.8. I need to make sure I don't lose them. Those are important. And I don't know where they are right now. Alright, here's my 1.8 millimeter nozzles. I just gotta keep track of them, make sure I don't lose them. Because they're they're gonna be very good for maximizing flow rate. Man, that was a mess. Getting this thing running is not great. Okay, so I'm just gonna keep feeding it all these random spools of red PLA. Bamboo Lab is not an actual 3D printer, it's an appliance. I think Bamboo Lab makes a good product. I just don't really like it from, I don't know. I just like doing weird stuff with printers, and they don't let you do anything weird. They're just like, use the printer as we intend you to use the printer. And also their stance on open source, being just completely anti-open source, is a little, sets a bad precedent for things. They don't even pretend to be open to open source. Well, I'm glad there's still so much excitement about this printer that we've still got 80 people in the chat a full 6 hours later. You know, this print should be going a little bit faster, but... Oh no, what am I doing? Okay, this is not going well. Okay, we'll just hand hold this a little bit. Okay. All right. For those of you loyal fans who have been watching for so long, I'm going to give you a sneak peek. No, Joe, thank you for the... Oh, the video's dead? What do you mean? Can you see the video? I'm shaking the camera. Compared to how it was almost 4 hours ago, this is incredible. Yep. Okay. Someone was complaining that it doesn't work, but must be one of those... Alright, there we go. Let's, hold on. Let me flip this around. There we go. Hello. Hello there. I think YouTube doesn't like handling streams this long, but that's too bad. Wait, you need a benchy over here to keep you company. There you go. Oh no. Things got a little too exciting in there. Oh no. Okay. I'll flip that back around. Okay, next up, red filament replacement. There you go, it feeds right in there. So, yeah, got a few improvements to make. I definitely think I can hit the 50 kilograms in 24 hours mark. I just need to improve a couple of things. Water sealed? What about water sealing? Is it waterproof? Probably. It could be. I could just spray it with some paint and it would disappear. Ducky 2. Oh, you want a ducky in the thing? Yeah, I need to build a phone mount on the inside of these large prints. Yeah, I'm not on the Perfect First Layer podcast anymore. So in the current configuration, no, it wouldn't hold water. It has a hole in the bottom. No, I don't have fuzzy skin enabled. It does have fuzzy skin though because of the gross amount of under extrusion. So I've got some code to basically do all the calibrations that I need to get it working better. I just wanted to run a bunch of prints because I'm moving soon and I want to just dump all of my filament out into some massive print and basically do a stress test of the design. The biggest bottleneck right now is just software and making sure the slicer is extruding the right amount, and also bed adhesion, making sure everything stays stuck really well. Both of them are easily solved. Maybe not so easily, but I've got solutions in mind. We'll get there. In due time. In due time. La di da di da. This is all so exciting, isn't it? 3D printing, technology. Iron Man. Iron Man, calm down. It doesn't look like crap. It's great quality printing. The next version, I swear I have some code that'll make it run a lot better. I'm just running the printer to test it out. You learn way more from doing a test and making some stuff that might look like crap than just kind of sitting in an armchair and being like, well, I could make this better. Let me keep planning on what I'm going to do eventually. No, Iron Man, I get it. Yeah, it doesn't look great right now. There's definitely room for improvement. And that improvement will come. I will make a second version of this with some software and firmware upgrades that I'm planning on adding. And that should help things out quite a bit. Right now, we're just pooping out a gigantic print just for, the sake of doing it and seeing what we can learn. You're right. Bamboo and Creality printers are perfect from the start, especially the A1. Except for the bed cable, but don't mind that. We don't like to talk about that. Oh, okay, well, we're running out of our first spool. Um, huh. If you were to redesign this from the ground up, what would be the biggest change you would make? Um, yeah, I'm surprised how well the A1 held up. Like, if the cables were actually under-spec'd or made out of a poor material or brittle or something, I would have expected them to break when I was battering it. So, it's kind of interesting to see. Just another data point. Valuable testing. Um, but yeah, that's the end of that chapter. Yes, ironing. Iron Man will iron the prints. I could have the tubes kind of like rub up against the outside and inside edges of the part and iron it as well. Although they have some bolts sticking out, so maybe I could like bolt on a special ironing attachment to do vertical walls. Frankie, I gave away the AMS. I'm sorry, I didn't destroy the AMS light. Was that part of the deal? I gave it to someone who came to buy some printers. Can we all agree that silk filament is pure garbage? Silk filament? Worst invention ever? You're taking a material that could form a strong, useful object and making it brittle and destroying its layer adhesion. I'm not going to use any silk filament on this thing because it's already going to be weak enough with the under extrusion. And yeah. Yeah, I made a robot out of entirely silk filament, and I didn't realize that it was garbage until I had it all assembled. And then it's like, well, now I have to print all those parts out again and put all the heat set inserts and take all the nuts and bolts out, and it's like, oh no. So anyone who uses silk filament is not a serious person. I don't mean to offend with that statement. It's just a statement of fact. All right. Yeah, silk is 100% useless. Silk is good for dumb trinkets. I agree. Yeah. One problem of making silk PLA toys is the layer adhesion is so bad. Like if you're printing a children's toy, it could have little parts that break off and could choke. I mean, it's a choking hazard. So it's just better to make things out of strong materials that we have access to. Yeah, I would like to move back into that place, but the timeline didn't match up. In my to the old NBR HQ, so I'll probably end up renting an office somewhere. It's kind of nice having it separate from my house, so I don't get printers everywhere. What's the best structural PLA? Just plain PLA. You don't need anything fancy. You need employees for that office? I can accept unpaid interns for now. I mean, if someone wants to buy some printers, you know, then maybe we could set up a little operation there. I've been really enjoying the PLA CF. I don't have a printer yet. I use silver for the handles on my drippy buckets. I don't seem to have any layer adhesion issues. Bring 2 printers. All right. You could be the dedicated quadrupolar printer operator. You basically have my job right now, where I just attend to the machine, make sure that it gets fed when it's hungry, make sure when it makes a mistake, I help fix it. It usually involves sticking your arm into places where it could get ripped off. Yeah. With hot pieces everywhere. Yeah, good idea. Check back later. This has been going for over 6 hours now. We're at 6.5 hours. I'm not printing as fast as I'd like to. So this isn't an ideal print speed. The G code has some issues. I need to put higher flow nozzles in. So, you know, we got some work to do. You didn't miss anything, Gareth. Um, 230 seems to be where PLA is happiest. Okay. Let's see what I'm running it at. I'm at 260 right now. I hate this. Every time I see it doing this, I'm like, what a waste of time. I know, I need to calm down. All right. Ah, oh no. Oh, this is always awful. Every time. Oh no. No. Okay. Okay. And hyper PLA. Mm. Okay. What should we switch that red to? We settled on black. Is red switching to black? Or I have this dark blue I can switch it to. Dark blue. Hmm. Okay. Oh. What the heck? Why is this happening? Crap. What the heck? Okay. There we go. All right, we're gonna run out of blue first. Rat. Come on. There we go. All right. You can do interviews from inside the can like the guy on the Sesame Street. I could just turn it upside down and wear it over myself like a cloak because it has the hole in the middle. It just works. It just works. Uh, yeah, it's 60 millimeters cubed. No, 73 millimeters cubed per second. 73.6 times 3. I mean, times 4. So that's almost 300 millimeters cubed per second, which is about 1.5 spools an hour. Which is why I have to keep changing these spools out. So that gray panel on the side, that's 1 kilogram. Same with that red panel on the right side, that's basically 1 kilogram. But essentially, this is just a scaled up version of this trash can, which everybody hated on because I used like, I don't know, $40 of filament to build it. And everybody thought, oh my gosh, you spent $40 on a trash can? But now, I've got my 20 kilogram trash can, $200+ in filament. Most of it's this Creality Hyper Series stuff, which is a little more expensive. So really we're looking at like a $300 to $400 trash can. It's gonna take bags this size. Use bags, big, you know. Okay, let's get this. I'm getting better at the filament changeover, you gotta admit. Oh, I'm not doing Z-hops actually. I thought I was. Super nice. Ah, all right. I can't believe people are still watching. Isn't this boring yet? Think of all the production pipelines that were traveled just to waste this filament and watch it. Yeah, most of this was shipped directly from China because these 3D printer companies they're like, oh my gosh, we need to send them some filament. And I'm like, okay, I'll take it. What's a smite match? Yeah, this is a lot of nonsense. Yeah, I agree. I mean, the reason you do stuff like this is to test it. And I'm going to have a trash can that I can use out of the deal. So that's not bad, if you ask me. I don't know if I'm going to like put some kind of surface finish on it or like sand it smooth. Oh. Yeah, I haven't played any MOBAs like Dota. I played the original Dota on Warcraft 3. And I didn't really, I don't know, it was kind of fun, but I didn't really like it that much. Um, it was fun though. I could see getting into it. So Toasty Boy, you heard of Smite when you were 13, so that was like last year, you think? Gotta ask, look at the filament spool and imagine the trash can that's stuck inside it. Uh, See, everyone that tuned in at the start, they were probably like, man, this is boring. Because there wasn't really anything to show, but now we've got some cool stuff to see. Just look at it. We got a big thing spinning around. Um, I'm going to do some math to see how long this is going to take. So, can someone tell me when I first installed the last spool of filament? When I did the, like, change to the red and change to that blue color? Like, back here in the timeline? Because it'll be that times 4, roughly, maybe times 3, in terms of how much time is remaining for this print. And I'm a little concerned that that might be a long time. That Galaxy Black looks cool. Oh no. I want the white to come in a little bit, maybe the red to come out. Holy crap. That's bad. Okay. All right. Okay, so the stream's been going for 7 hours. I've gone through about 6 kilograms of, maybe a little more, maybe 7 kilograms. So I'm going at about a rate of 1 kilogram per hour, which is about half what I was planning. One kilogram an hour. That sounds really lame, doesn't it? 1 kilogram an hour? Yeah, the print quality isn't great because I haven't tuned the extrusion to be consistent from the inside to the outside. And also I have some bed adhesion issues. You can see down there, it's like lifting off the bed. So there's more to work on, definitely. Yeah, Iron Man, come on. Give me some sick burns. I need to be roasted. Uh, did I block? I think I timed out Iron Man, but only for 5 minutes. Faster than what I can print. Yeah. If I didn't have all these retraction moves, I would be closer to, like 1.25 kilograms an hour. And then if I put the 1.8 millimeter CHT nozzles on there, I'd probably get 1.5. Yeah, I mean, there's more work to be done here. That's for sure. Mm. Well, I don't want to be here for 24 hours. Although I guess I could. Just leave the printer running. Like, realistically, I can probably be here another 4 hours before I have to go to bed. Which will be enough to get one more filament change out. That'd be another 8 kilograms. Ever since we got past those initial layers, I think we're running a lot more reliably now, at least. You could go faster. Need some pizza? Oh no. I guess I could pause it, but I'm worried that if I turn the heated bed off, it's going to self-destruct, which obviously wouldn't be good. All right, I'll just leave my phone here recording, and then I'll watch on my computer at home, and if anything goes wrong, I'll drive out here in time for it to be completely unsalvageable. That's a great idea. Just trust us. Okay. I mean, if you hit the like button enough, it'll fix any problems that come up with the print. Crazy glue it? Yeah, that could work. Honestly, it's about time I go get something to eat, so I think I'm going to end the stream here and just go dark mode. And then you guys are just going to have to stay tuned for the update video. So make sure you're subscribed, gosh darn it. Even though I know most of you are probably subscribed, that's just how live streams work. Know your Joe? Yep, thanks. Anybody got last words? Or, I don't know, right now I'm in the hole with filament. We've put about $80 to $100 worth of filament in there. And we've only got $46 of donations. Oh, there we go, 99 cents. I'm gonna buy 1/10 of a spool of filament with that money. Thank you, Cheesy Bites. Yeah. I mean, I hope this thing finishes up, but also, I have to, oh, Cheesy Bites, you weren't subscribed, how dare you? The 99 cents makes up for it, though. Yeah, the stream is at 5, 6, 7, yeah, we're at the 7-hour mark. Intended Z height for this print is 29 inches, which is the standard height for a residential trash bin. So 29 or 39 inches, I'm not sure. I think it's 29 inches. Yes, know your Joe. You got the notification squad. All right. Well, stay tuned for the exciting conclusion of the perpetually printing trash bin. It's been very exciting to just see this machine work. Like, I'm super stoked about it. So, you know, it's finally kind of leveled off to a point where I think it'll just run. Now that all the bed adhesion and other miscellaneous issues have sorted themselves out. So, I suppose I need to do a sign off here. I want to see a trash company actually pick this up. Yeah, they'd probably get confused and just throw the whole thing in the dumpster. But yeah, giant printer is printing away. Woo. Look how big it is. Look how big the printer is. My hand fits in there. The Benchy is eclipsed by the rest of the print. I'm gonna run out and get a bite to eat, so that I can like eat dinner and then come back to this in time to switch out some of these spools. I think I've got about an hour to get back here and keep an eye on it again. So thanks everyone for tuning in. This has been a huge success, both in terms of viewership and just the machine actually working for the most part, and doing some troubleshooting and figuring out how to get this thing going. So yeah, whoop, whoop-de-doo. That's awesome. Yeah, I'll make sure to do a YouTube community post. So if you're subscribed, you should be able to see that. And if you're following me on Twitter or something, I'll probably tweet about this. So yeah, exciting stuff. Thanks for watching, everyone. Let's check for any last minute. Yep, we're all good. Any last minute messages from the my loyal fans? Want to see the trash? Yeah. No, I think we're all good here. 3D Chameleon would give you the access to automatic filament swap. There you go. I need an automatic filament swapper on here, or 4 of them. That's an idea. So yeah, we'll figure that out later. Thanks, Chad, for the compliment. All right, I'm logging off now. Time to go get some food. See ya, everyone. Boop, boop, boop.